Hi everyone, let's evaluate this piecewise function on various values of x. Example 1, let the function f be defined by the following piecewise definition. F of x equals x squared if x is between -2 and 1. X could be -2. We have a weak inequality here. And f of x equals x plus 1 if x is between 1 and 2 inclusive, including the endpoints x equals 1 and x equals 2. So in other words, if x is in this subdomain, we square the input. If x is in this subdomain, what do we do with the input? We add 1 to it. So we have two different rules that do two different things depending on where x is. 4 questions for you. What are f of -1, evaluate that, f of 1, f of 10, and what is the domain of this function? 4 questions for you. Evaluate these 3 function values and find the domain. I'll give you 30 seconds. Okay, let's begin. I'll tell you what a lot of students do. A lot of students look at the question, evaluate f of -1, please. All right, let's look at f of -1. Here's what a lot of students do. Oh, if I plug in -1 for x in the top rule, I get the square of -1, which is +1. If I plug -1 into the bottom rule, I get -1 plus 1, which is 0. So I guess f of -1 is both 1 and 0. Is that right? No. You may get no credit for this because you don't know what a function is. Take a look at this. If you claim this, you're claiming that the input value of -1 in the domain, it is in the domain, you're claiming that if we input -1 from the domain into this function, that it's spitting out a +1 and a 0 at the same time. A function is not allowed to do this. If you input a value from the domain, you cannot get 2 or more different outputs or y values. This cannot happen. So don't just take the input value and plug it into all the rules you see. You have to pick the rule and pick a final value. So which is it? Is it the 1 or the 0? Well, where's the -1? To evaluate f of -1, we use the top rule. Because to evaluate f of -1, we only care about what happens when x is -1. Which rule applies? Only the top rule. -1 satisfies that compound inequality up there. It does not satisfy the compound inequality down here. So -1 is in the top subdomain. Therefore, we apply the top rule. F of x or y equals x squared. What do we do with the input? We square it. The square of -1 is +1. The final answer is 1, not 0. The bottom rule has absolutely nothing to do with x equals -1. 0 has nothing to do with the answer. Again, if you put 1 and 0, you may well get no credit. You don't know what a function is. So f of -1 is 1, which means that the point -1, 1 lies on the graph. If x is -1, then y is +1. All right. Now, what about f of +1? I have to erase all this. Which subdomain and which rule will apply if x is +1? It's a close call this time, but if x is +1, the bottom subdomain applies. 1 is in the bottom subdomain because of the bar there. That's a weak inequality. See, over here we have a strict inequality. 1 is excluded from that subdomain up there. So x equals 1 only applies to the bottom subdomain, and therefore we only apply the bottom rule. What do we do to x equals 1? We add 1 to it. So to evaluate f of 1, we use the bottom rule because 1 is just barely in the subdomain on the bottom. So we use the rule f of x equals x plus 1. The x square rule has nothing to do with this. F of 1 equals 1 plus 1. F of 1 turns out to be 2. Box that in, that's it. That's the value of f of 1. Now, what about f of 10? Well, there's no rule for x equals 10. Neither subdomain applies, neither rule applies. Therefore, 10 is not in the domain. F of 10 is undefined because we have no rule for it. And by the way, what is the domain? It's the closed interval from -2 to 2. Why? Because that's the union of these subdomains. The domain of f is the union of these two subdomains. So the lowest value in the domain, there is a lowest value, is -2. Sometimes there is no lowest value. You have a negative infinity deal going on, like for absolute value. But here, -2 is the least value in the domain. We walk on along. We just barely miss the 1, right? We miss the 1. But wait a minute. We pick up the 1 in the second subdomain. So there's a save. 1 is saved. 1 is in the overall domain. It's saved by the second subdomain. And then we walk along until we get 2. 2 is the greatest number in the domain. So we do get all the real numbers from -2 to +2, including the 1, which was especially risky because we changed rules at 1. But because of the bar there, because we had a weak inequality here, the 1 is still included in there. The domain is the union of these subdomains. Basically, the first subdomain is bracket -2, comma 1 parenthesis, union. Second subdomain is bracket 1, comma 2 bracket. The union of these subdomains is this over here, the overall domain. So f of -1 gives a real number, f of 1 gives a real number, but f of 10 does not. F of 3 does not. F of pi does not. F of -pi does not, because pi, -pi, they're not in the domain. Next up, how do we graph this function, this piecewise function?